You need to find the unit of the rate constant. Very easy task. But before that, you need to be very much sure about the order of the reaction. What the order of the reaction is there, because unit of the reaction, unit of the K depends on the order of the reaction. So unit of the K depends on the order of the reaction. So you need to find out unit of K depends on order of the reaction. Order of the reaction. So basic responsibility is to find out the order of the reaction, and that can be calculated by the statement itself. What they are telling? The concentration of B alone was doubled. The half-life did not change. Half-life doesn't depends on the initial concentration only for the first order reaction. First order reaction. This one is the litmus test. This one is the litmus test that for first order reaction, the half-life doesn't depends on the initial concentration. We are talking about the half-life. We are not talking about the time period. Time period depends on the initial concentration, but half-life doesn't depends on the initial concentration. Okay. Then it's a first order. It's a first order with respect to B. Okay. R is equal to K, concentration of B. Now we need to find the concentration, we need to find the order of A with respect to the given statement. The concentration of A alone was doubled, okay. The rate increased by 2 units. I told you what the shortcut is there. Rate becomes twice, okay. And this depends on the concentration that became twice. So this concentration became twice, rate became twice. So N should be equal to 1. It means it's a first order reaction with respect to A. But what's about the overall reaction? So R is equal to K concentration, let it be concentration of A and B. So it's a basically second order reaction. So this one is basically a second order reaction, and we need to calculate the unit of the K based on the second order reaction. So as far as second order reaction is concerned, this can be written as K is equal to R and let it the A square. You can write A into B, but I have written simply A square because it's a second order reaction. So K is equal to mole by liter into 1 by time. It's written second, so I will write second divided by moles per liter whole square. Moles per liter whole square. So once you cancel it, it will be the liter mole inverse second minus 1. Once you solve it, this is going to be cancelled. 1 mole per liter is going to be cancelled. 1 mole per liter will be remaining. Just change the sign. Liter will come up, so it will be the liter. Mole negative, and only time is there, second inverse is there. So option 1 is going to be the correct answer. Option 1 is going to be the correct answer. You need to select the best option. In the first statement, they have told that it's always a multi-step reaction. 2 parameters are there. Number 1, order doesn't have to do anything with the order, has no relation with the multi-step or single steps. There is no relation at all between the order of the reaction or number of steps in the reaction. Order simply depends on, suppose R is there, it's a K raised to power X, B raised to power Y. So order is very simple. Order only imply on X plus Y. Doesn't depends whether it's a single step reaction or multi-step reaction. So this one is, because of this word we can ignore this, or because of this always word, this came out from the race. Now in option number 3, once again the always word is there, so it also came out. Now in option number 2 and 4 there is no always word. We need to focus. If it is zero order reaction, it is basically enzyme based reaction. Either it's an enzyme or decomposition of gas on a metal surface, or it's a decomposition of gas on a metal surface. Decomposition of gas on metal surface. And majority of them are multi-step reaction. Majority of them are multi-step reaction because they form a reaction intermediate which keep on decomposing. So basically they form reaction intermediate which keep on decomposing until a final and stable product has been formed. So can we cite the example for this one also? If the statement is that most of the time it has single step, multi-step reaction. Is any example exists where it is a single step reaction? Answer is the decomposition of ammonia. The decomposition of ammonia is a single step reaction. Decomposition of ammonia is a single step reaction. Decomposition of NH3 is a single step reaction. Of course, we are discussing the part that can be considered as exception to this part. So we need to select the most suitable option. So second is the most suitable option. Fourth is not the most suitable answer because they are focusing on the exceptional behavior. Answer is option number 2. This one is one of the most popular type of the first order reaction. What I need to do? I need to write the two equations, one corresponding to T 1/4, second corresponding to 3/4, and just compare them. Just divide equation 1 by equation 2, you will get the answer. In this case, the first part is T1 is equal to, it's a 2.303 divided by K log initial concentration minus the concentration that has been left. So we can say it's a A0 minus X. Now we know that K is equal to 0.693 by T half. We will put it here itself. So it's a 2.303 divided by 0.693 multiplied by 8 log initial concentration A0, and what is left? 1/4 has been consumed, so 3/4 has been left. Cancel the A by A. So this can be rewritten as 2.303 divided by 0.693 into 8. Now it is log 4/3. It is 4/3, which is 0.125. So this can be written as 0.23. This can be written as 2.303 into 8 into 0.125 divided by 0.693. This is first statement. Now for T2, the same equation can be written as, it's a 2.303 divided by 0.693 by 1. So there is no need to write 1. Multiplied by this time 3/4 has been consumed. It means 1/4 is going to be left. So it can be written as log 1/4. Log 1/4. Now this has to be written like T second is equal to T is equal to 2.303 into 0.693, and this is 0.602. This is 0.602. Now compare T1 by T2. If I go for T1 by T2, so which is going to remain? This 2.303 is going to be cancelled. This is going to be cancelled. Now this is 1 and this is 0.602. It is 1 and it is 0.602. So 1 and 0.3, this is incorrect statement. 0.125, 0.623 incorrect. 0 has been missed. So this is incorrect. So last answer is fourth is the correct statement. You should be careful that there is no 0 before this. So to make it correct, I need to put the 0 before this. So fourth option is there, none of the following, none of the above, and this is the right answer. This one is a formula putting problem and simple calculations are there. For example, we know that for the first order reaction, it can be written as Kt is equal to 2.303 log A naught by A. And what is the A naught? A naught is 100. So it is 2.303 log, this is 100. And after loss of 60%, after loss of 40%, 60% is going to remain intact. So this is 1.6. We need to find what the value of K is there. So K can be written as 2.303 log 1.6 divided by 560. You will be trapped because here this value is given in second, whereas the options are included in the minute. It means at the last stage you have to convert second into minute, otherwise you are going to get a wrong answer. So log 1.6 means log 2 is equal to 0.30. Log 2 is equal to 0.30. So log 1.6 is precisely it is 0.22. Now K can be 2.303 multiplied by 0.22 divided by 560 second. This is going to be 0.0009. Let it be 91. But the unit will be in second. Unit will be in the second. Unit will be the second inverse. I need the answer in the minute inverse. So it's a 0.0009 by 60. This will be something around 1.5 into 10 raised to power minus 5. You will see that this type of options are not included here. So answer will be fourth. This question is having a history also. This came in a special NEET paper that was applicable for 1,000 students only. In that case, all 4 options were wrong. So I kept the option 4, that is none of the following. So which is going to be true in every case? Let's see. The overall order equals to the sum of the reactant coefficient in the overall reaction. But it is valid for elementary reaction. Valid for elementary reaction only. Valid for elementary reaction only. The overall order becomes equal to sum of the reactants coefficient in the slowest step reaction. But we don't know what will happen to the reaction intermediate. If the reaction intermediate is there, that is going to be changed. The structure of the catalyst remains same. If it is remains same, then how the structure can be changed? Catalyst, some of the catalysts are there. For example, shape selective catalysts are there. Their shape has been changed. Shape gets changed during the reaction. So shape has been changed. Shape is going to be changed during the reaction. So it cannot remain same. This one is also incorrect statement. The rate law includes all reactants in the balanced overall equation. This is written rate law. So we know that we write it like d by dt. So in that case, this is going to be valid, else everywhere certain limitations are there.